Hi there, welcome to another video for Cert or Level Maths, continuing with arithmetic in financial maths, and now starting to look at compound interest. So this is where we're starting to earn some money back rather than being taxed. So dealing with banks and credit unions and lending institutions, all to do with compound interest. If we invest €100 in a bank at 4% per annum, which means annually or per year, at the end of the year, we will have earned 4% of the €100. So we'll have earned €4. So then we have €104 in the bank. So €104 is 1.04% of what's called the principal. The principal is the amount of money we invested at the start. So in this question, the principal was €100. €4 is the interest earned. 4% was the interest rate per annum. And €104 was the final amount or the final value of it after 1 year. When we're doing calculations to find the interest, we'll use the percentage interest, we'll change that to a decimal. So 4% will be 0.04 when we're using calculations. There are rules around percentage rates for our own customer protection. When banks are advertising for loans or mortgages, they have to give us the annual rate. So that's called the AER, annual equivalent rate. So that's the rate of interest for 1 year. Or it could also be called the APR, the annual percentage rate. They have to state them, because that means you know what you're getting into. They say it very clearly at the start. Compounding then is where if the €100 was invested for 4 years, instead of just for 1 year, it was for 4 years. Well, using compound interest, that means the interest is added to the principal at the end of the year. So at the end of year 1, we'd have €104. So now that's the new starting amount. We're starting with €104 at the start of year 2, and we're going to add on 4% to that, and it'll bring us up to €108.16. And then at the start of year 3, we're starting with €108.16, and we're adding on 4% to that. So we get up to €112.4864. And at the start of year 4, we're starting with the €112 and getting 4% out and adding it on. So at the end of the 4 years, you have €116.99. Now, you're not going to get 4% interest down at the bank, because the interest rates are currently so low that you might actually have to start paying the banks to hold on to your money instead of them paying you. So 4% would be fantastic right now. What happens then if you have like a 30-year mortgage and they're trying to figure out how much the interest and things like that are going to be? You're not going to stay doing that manual compounding all the time. So what we have is a formula for it that does it all in one go. And it's on page 30 of your log tables. Here it is. F stands for the final amount or the final value of it at the end of the term. So if you have a 30-year mortgage, this F figure will be how much it will be worth after the 30 years. P is your principal amount, so your starting amount. T stands for time, how many years are you putting it in for? And I stands for the rate of interest. And this is where it's important that I was saying that the interest rate is used as a decimal for these calculations. So there's a big difference between putting in your interest rate as 4 or as 0.04. You want to put it in as the 0.04 as decimal. This formula only works once the interest rate stays the same for the entire term and there are no deposits or withdrawals from the account. So nothing really changes, it just compounds on top of itself for however many years. Looking at an example of it, Use the formula to find the value of €100 invested for 4 years at 4% APR. Okay, so F is our final amount that we're trying to find. P is our principal starting amount, so that was €100. T is the number of years, so that was 4 years, and the interest rate was 4%, so the interest is 0.04, putting that in as a decimal. Filling into our formula then, F equals 100 times 1 plus I, which is 0.04, close your bracket, and that's all to the power of T, so to the power of 4 years. Your calculator will do this, and it comes out as €116.9858, so that is €116.99, which is what we had when we manually compounded it up here. After 4 years, I went in and I got 116.99, and using the formula 116.99. Quite a nice formula. That's a straightforward example. That's the typical type of question you'll get. And then a later part of a question might be to calculate the interest rate. So this is a little bit more involved. Interest can be charged daily, weekly, monthly, or yearly, and we can convert between them using 1 plus I to the power of t. So if we look at our formula for compound interest, the final amount equals the principal times this, which is like the interest getting added on. So if we just look at that part there, that's like the interest part. So the credit card company charges you every month, and there's 12 months in the year. So if we want to convert that interest rate to a yearly rate, we're going to say that the time for the credit card company is 12 months in the year, and the annual rate, the time, is going to be 1. And we're going to set these two things equal to each other. So 1 plus the interest times the time is going to equal 1 plus the interest times the time. And we're going to go from 12 months into a year. 1 plus the interest rate for the credit card was 0.03, so 3% for 12 months. And we're going to find out what that interest rate is if we converted it to a yearly amount. 1.4257 equals 1 plus I. We want to get I on its own, so we're going to subtract I from both sides, and we're left with 0.4257 equals the interest rate for the year. But that's given as a decimal, so it's not 0.4257%, it's 42.57% per year. So you can see how credit cards can be very expensive. They might say, well, it's only 3% per month, but when you convert that into how much it is per year, it's 42, nearly 43%. So you need to be paying off that credit card bill at the end of every month. And also, you know how we were saying they have to legally advertise AER and APR? You're not seeing that many credit card ads on television anymore, because if they were to advertise that it was 42.57% for the year, that's quite off-putting. Another example then is where Aidan invested money in a 5.5-year bond when he started first year. So he put this money into a savings account. In the middle of 6th year, the bond matures and he has earned 21% interest in total. Calculate the AER for this bond. Okay, so we don't know how much he put in, but we're just trying to figure out the interest rate. So let's say that the principal he put in was 1. He put in €1. It just makes all the calculations a bit easier. So if he put in €1, he earned 21% on that €1. So when he came out in 6th year, he had €1.21. His time was 5.5 years. And now we can put that into our formula. We know the final amount was 1.21. His starting amount was 1. And we don't know the interest rate, but the time was 5.5 years. I want to get that interest rate on its own, so I need to deal with this indice here. You'll remember from indices, if I wanted to get rid of that, I'll take the root, but it'll be 5.5 to the root 1.21 equals 1 times 1.5. So I did the opposite of putting it to the power of 5.5. I took the 5.5 root. This works out to be 1.03526 equals 1 plus I, just multiplying that 1 into the bracket. Want to get I on its own, so I'm going to subtract 1 from both sides, and I'm left with 0.03526 equals I, but we're asked to find the AER, so the equivalent rate, the percentage rate, so I need to multiply that decimal by 100, and it comes out to be 3.526% is his interest rate, is his AER. Those last two examples are difficult. Using the formula here straight up just to find the final figure, you would be expected to do that. The other two would be getting into 6th year work. Hope you found that useful.